Assalamualaikum, Bismillahirrahmanirrahim. Okay, now let's continue on the more examples of the Phasor transform. So as we recall, we have two type of the representation. The first one is sinusoids. So this is represented by the time domain, and another one is what we call phasor. Phasor is in the form of the amplitude and the angle. Okay, so in order for you to have the phasor, you need to make sure it is in the cosine form. So if you see here, Vm and Im both are in cosine, right? So you can directly convert this one to the phasor form. There is Vm towards the angle, and also the current Im towards the angle. So let's say you are given a sine. So the first step, always change sine to cosine if you work on the phasor form. Okay, so how you change it? So this one is cosine, this one is sine. This is minus cos and minus sine. Okay, so in order for you to change from sine to cosine, and then you go here, and this one is a counterclockwise, so this where it is minus 90. Okay, so in your phasor and in your time domain, there is a sinusoid or sinusoid. We call the function by time vt. But if you change from the sinusoid to the phasor, your v is no more become vt, it become the ball voltage. So you can see here the v should be emphasized here. Okay, so in phasor, this v is not time dependent. In your sinusoid, your v here is time dependent. Okay, in your v, it is a frequency of phasor domain presentation. In your sinusoid, it is a instantaneous or time domain. So if we can make summary here, this one is a time domain. For your phasor is actually is a frequency of phasor domain. Which one is time dependent? It's a sinusoid. For the phasor, it is not time dependent. Okay, so in your VT, it is always a real number. There is no complex number. But in your phasor, all is about the complex number where we have a real and imaginary. Okay, when you are going to compare, you see here, phasor analysis applies when the frequency is constant. So when you are going to compare between two signals, one is V1, another one is V2, both need to have the same frequency, cyclic frequency or the angular frequency. You can't compare if it is opposite. Okay, so let's see how you're going to solve this one. So this is example 9.3 from the books. So let's go to the A. Okay, first this is in a polar form, right? So you need, when it is addition, you need to convert this one to the rectangular form. So for 40 to 50, it becomes 4 cos 50 plus 40 j sine 50, okay, plus 20 cos minus 30 plus 20 j sine minus 30. So let's solve the inside first. So this is one function. So when you press your calculator, you can get 25.71 plus j 30.64, and this is another function of the polar form of the phasor. It has been 70.32 minus j 10. So you just add this one together, and then you can get 43.03 plus j 20.64. Okay, so this is in the rectangular form, but we are not finished yet. So you have a square root here. So if you remember in the previous slide, when you have a z square root, means what? you are going to square root the phasor, right? So how you're going to solve this one, you need to make sure this one is always in a polar form. So you need to change this one to the polar form. So just press your calculator and then you can get, let's say this is A or Z. So your Z here is equal to 47.72 angle 25.63. Or you can do manually. How you can get the angle? Theta equal tangent inverse 20.64 divided by 43.03. Okay, how you can get the R? So R equals square root 43.03 squared plus 20.64 squared. So once you got this in a polar form, so what you need to do? So if Z is equal R theta, square root Z is equal square root R angle theta over 2. So this is how you're going to solve the square root of the complex number. So means your Z half here is equal to square root 47.72. You divide the angle by 2. 25.63 divided by 2. And finally, you can get the answer. That is 6.91 angle 12.81. So the answer is the same. Okay. So this is how you solve the complex number. Okay. So for part B, you can do by yourself. So when you see the addition, so means you need to change this polar form to the rectangular form. And when you see the multiplication, you need to change this one both to the polar form and then you conjugate it. So what does mean by conjugate? So let's say this one x plus jy. So to conjugate it, it becomes x minus jy. Or if it is in a polar form, r angle theta, z's conjugate is r angle minus theta. Okay, so I leave this one to you for you to solve it by yourself. Okay, now let's see the next example. So now you have two functions. One is I1, another one is I2. So for I1 is already in cosine form. So in order for you to solve this one, the question one, I1 plus I2, right? Okay, so first phase, change this to the phasor form. For you to change the phasor, it need to be cosine. So the first one is already cosine. So you can change the phasor by changing this to capital I is equal to 430. Okay. So once you got I1, let's move to the I2. So I2 is equal 5 sine omega t minus 20. Okay, now look at here. This is sine. In order for you to change the phasor, it need to be cosine. So let's change it to cosine. So here is cos, here is sine. Okay, you are given a sine, you need to change to the cos. So what does that mean? Cos need to go to the sine. So cos need to go to the sine. So this is a counterclockwise minus 90. So you got here WT minus 20 minus 90. So your I to t here is actually 5 cos omega t minus 110. So once it's already in cosine, you can change this to phasor. Okay, so it become I2 is equal to 5 angle minus 110. So now you already have two functions. One is I1, another one is I2. So what you need to do now, you need to add together. So total I is equal I1 plus I2. So your I1 is 4 angle 30 plus 5 angle minus 110. So when it is addition, always change to the rectangular form back. So it become 4 cosine 30 plus 4j sine 30 plus 5 cos minus 110 plus 5j sine minus 110. Okay, so this is the long way. Or you can just use calculator to change it from the polar form to the rectangular form and directly write the answer. So for this one, when you change to polar to the rectangular, so how much you got here? 3.464 plus j2 minus 1.71 minus j 4.698. And then you just add together real and real, imaginary and imaginary. It become 1.754 minus j 2.698. Okay. So now you want to leave your answer in term of it equal what cosine. You want to leave your answer in the sinusoid form. So what you need to do now, change this one to polar back. So just use your calculator. So then you can get 3.218 angle minus 56.97 degree. Okay, so how you change this to the sinusoid? Okay, this is IT, right? It is in a phasor form. So it become I total t is equal 3.218 cosine omega t minus 56.97. Don't forget the unit is ampere. Okay, so just remember your aim. So your aim now is always change the sinusoid to phasor first. In order for you to change to phasor, you need to be cosine. If you given sine, you need to change to cosine and leave your final answer in terms of sinusoid again. Okay, so I hope you can do your practice and then we will discuss more in the next video. Assalamualaikum.